you throughout this video, I will be presenting you with information that supports the idea that the insect species Bactrocera oleae, better known as the olive fruit fly, indeed is a leading cause for the greatest loss experienced by olive oil producers.
Howdy, my name is Brady, and as Abby mentioned, during this debate we'll be going through and presenting information on how olive trees are affected by different insect species, and I will be explaining my reasoning to why I think Homolodisca vitropenes, which is commonly referred to as the glassy-winged sharpshooter, has the most impact on olive trees.
I feel that it is important to start with the life cycle of the olive fruit fly to better understand the ways in which this species impacts olive production. Here's a short summary of its holometabolous metamorphosis. First, a female olive fruit fly will deposit a fertilized egg beneath the surface of the olive. Second, after this deposition, larval development begins, typically spanning 2 to 3 days. Third, as the larvae mature during an 8 to 37 day span, their only source of nutrients is the pulp of the olive. Fourth, pupal development occurs either inside the olive or, as the larvae exit the olive, into the soil surrounding the olive plant. Fifth, a physically and thus sexually mature olive fruit fly emerges, ready to begin the life cycle again. With this background, the burdens of Bactrocera oleae placed on olive production can be better understood. Looking at the deposition of the fertilized egg in the larval and pupal stages of development, the most troubling aspect of the species' impact becomes apparent. When a female olive fruit fly deposits their egg into the fruit, the plant is molecularly impacted. Genes responsible for stress response, phytohormone signaling, transcriptional control, and primary metabolism are impacted. In the larval stage, the loss of olive pulp decreases the fruit's connection to its source of nutrients, the host tree, thus leading to increased levels of fruit drop. In the pupal stage, the exit holes left by the larvae leave the plant susceptible to infection and phytopathic agents. One such agent, olive anthranose, can lead to 100% loss of fruit production. Of 3.27 million tons of olive oil and 2.6 million tons of table olives produced in 2002, 580,000 tons of olive oil and 458,000 table olives were lost due to olive pests, solidifying the important role of the olive fruit fly in olive product production. Because of this, the olive fruit fly poses massive threats to the production of olives and thus to farmers, industries, and consumers alike.
I think the way that Homolodisca vitropenes, which is the glassy-winged sharpshooter, impacts olive production is in how they transfer the plant pathogenic bacterium Xyla fastidiosa from one plant to another. The reason that the glassy-winged sharpshooter has such a negative impact and is able to spread this disease is because when exposed to this bacterium, the insect attaches different mouth parts, which basically carries over the disease from one plant to another. This plant is the olive tree, and since the glassy-winged sharpshooter can so easily transfer it, the insect becomes a significant threat to these trees. This bacterium, also referred to as a disease, is extremely harmful to the olive production because of how it completely takes over a healthy living olive tree. The steps consist of multiplying bacteria and forming biofilms in the xylem, which blocks water and nutrient uptake to the main parts of the tree, which can result in different symptoms, including wilting, leaf scorching, and the overall death of the tree. Since this bacterium, Xyla fastidiosa, is so harmful, it makes the glassy-winged sharpshooter such a dangerous threat to olive production because of how fast these insects can spread the disease. The glassy-winged sharpshooter is a very quick and mobile insect, and as a result of this, the disease can get around very efficiently and very quickly. This unique characteristic results in long-term decline in olive tree orchards, which creates severe economic and agricultural losses. The progressive decline in these trees, once infected, is something that can't be stopped. Think of it as a rusty car. Once a car is exposed to the elements that cause rust, there's really not much you can do to slow down the inevitable rust. With Xyla fastidiosa, once the glassy-winged sharpshooter transfers its disease, there's no saving the tree, leading to, as I mentioned, orchard removal and continued agricultural losses.
I would like to draw your attention back from Brady's argument and to the impacts that I mentioned previously, particularly to the fruit drop that is linked to larval development as they consume olive pulp and to the potential impact of olive fruit flies as a pest could reduce olive production by 15%. This amounts to a financial loss of 800 million US dollars. As of 2013, 3.6 million tons of olives were lost due to Bactocera oleae. These are unignorable numbers. It's important to remember that this insect is affecting the entire olive chain. Farmers with productivity loss and lower income, industries with low quality fruits leading to low quality products, which inevitably lead to lower income, and consumers who have products with reduced quality, benefits, and nutritional value from olives.
While undoubtedly the olive fruit fly harms the olive production by reducing the amount of olives produced, this impact is significantly smaller compared to the glass-hewing sharpshooter. The long-term devastation caused by the glass-hewing sharpshooter strongly outweighs the manageable impact that the olive fruit fly makes. While the olive fruit fly does make an impact on olive trees, the fly primarily impacts the fruit itself, where the transmission of Exila fastidiosa, which is transmitted by the glass-hewing sharpshooter, targets the entire tree, which results in a mass destruction of the trees, not just the individual fruit. The olive fruit fly impact is significant, but also treatable with different types of pest management, like insecticides or pesticides. Once the Exila fastidiosa comes in contact with an olive tree, there's no cure for the disease, and the tree is going to die. To stop the spread of this disease, the trees would need to be uprooted and destroyed, which overall causes economic loss, as I mentioned.
Thank you, Brady. I would like to shift your attention slightly, as I believe it is important to address the downstream economic effects that the olive fruit fly poses, as the economic burden does not solely come from the loss of the plant itself. The downstream effect is related to the research of these insects. An example, their life cycle, reproductive behaviors, and their feeding behaviors, and the development of ecologically mindful pest control procedures. It is estimated that farmers, the first level of humans impacted by Bactocera oleae, spend an average of 100 million US dollars on pest control, 50% of this money corresponding to pesticides. Also, it is important to recognize that the aforementioned numbers do not include the financial weight of the adverse environmental effects of these pesticides. Not only are these pests directly impacting the olive production economy via their harmful development stages, but also indirectly via the money needed for research and pest control development to limit the olive fruit fly's burden.
I think the olive fruit fly poses a strong economic burden, as Abby mentioned, but it is all an issue that can be maintained and kept to a smaller number, even with this burden. The investment listed can and have proven to slow the spread of olive fruit flies. To counter this, looking at the glass-hewing sharpshooter, there's nothing to slow the spread of this disease once in contact with the tree. The incurable disease is something no pest control can fix, and it overall leads to the death of these trees. The thing about trees that have problems with the olive fruit fly is that they are not fully gone. They can still be salvaged to maintain the olive production, even if it's at a costly expense. Olive fruit flies are inconvenient to say the least, but it's important to note that once a tree is hit with the disease carried by the glass-hewing sharpshooter, it's a done deal and there's nothing you can do to save it. No amount of money you can spend to cure the disease. In southern Italy alone, the financial toll that has come from the loss of olive trees because of Exila fastidiosa carried by the glass-hewing sharpshooter exceeds a scary 20 billion. Basically, in simple terms, the olive fruit fly is a contained inconvenience, where the glass-hewing sharpshooter is a significant threat to the entire industry.
In conclusion, let's quickly recap the damage that the olive fruit fly directly and indirectly places on human society. Directly, millions of dollars are lost in the production of olives due to the natural life cycle of Bactocera oleae. Specifically, loss in olive production because of fruit drop and the potential threat of infectious agents. Indirectly, millions of dollars are used in the research of the species as researchers seek to better understand the olive fruit fly life cycle and reproductive behavior, and as research pushes for more ecologically minded pesticides and other pest control methods. Again, it is important to remember that this insect is affecting the entire olive chain, including you and me as consumers. Farmers with productivity loss and lower income, industries with low quality fruits, and consumers who have products with reduced quality and nutritional value from olives. For this reason, Bacterocerra oleae, the olive fruit fly, causes the greatest loss to olive production.
To recap, the impact that glassy wing sharpshooter has on olive production lies in the transmission of the disease Extyla fastidiosa. This disease is transferred to the olive tree, and once it's transferred, then there is no stopping it, leading to a total loss, which has negatively impacted local and global scales. The major role that Extyla fastidiosa plays strongly affects these trees, leading to the different outcomes of olive trees. Studying this is so important because this is a problem that can and has impacted agriculture, and being able to know what to test to try to prevent the spread of this disease is so important and can make such a big difference. The transmission of this disease is spread through the glassy wing sharpshooter, but killing off the insect might not be the only solution to fixing this. Resulting in this, it makes it clear as to why it's important to study the different effects and how this disease, Extyla fastidiosa, transmitted by Homolodisca vitripinis, can be slowed down to help global scale economies.